Hello, this is Jeffrey Frankel with Solutions in Chemistry. Today I'm going to talk on the topic of acids and bases in IB Chemistry HL Paper 1. This is Calculations 5, and you can do these questions in less than 30 seconds.
There are different ways of answering this question. If you go back to pKw at 25 degrees centigrade, pKw at 25 degrees centigrade, you know that it equals 14 or 14.0. And you know that pure water at this temperature has a pH of exactly half that, 7.0. Therefore, you can go to that information, pKw at 10 degrees centigrade equals 14.54, and you can say that the pH of pure water is 7.27, which is this. The first thing is, how do I know this is right? But the first question is, how do you know that pH of pure water is 7 just because the pKw of water is 14? And the reason you know it is because when you convert this back into kW, kW equals 1 times 10 to the minus 14. That equals the concentration of hydrogen ion times the concentration of OH minus. And they are equal in pure water. And when the pH is neutral, they are equal. And therefore that can only happen if they're each 1 times 10 to the minus 7. And that is 1 times 10 to the minus 7. So they can only be true when both concentrations are exactly the same. 1 times 10 to the minus 7, 1 times 10 to the minus 7. So if I go over to this, and you follow this argument, the kW, so that's at 25 degrees centigrade, and this is at 10 degrees centigrade. That must mean that it's 1 times 10 to the minus 7.27 times 1 times 10 to the minus 7.27. That's there. So that is the long argument of proving that that is the correct answer. The hydrogen ion concentration must equal the hydroxide ion concentration. And if this is the kW, or if this is the pKw, then this must be true. That must be the value of the hydrogen ion concentration. That must be the value of the hydroxide ion concentration. If the pKw is 14.54 and the kW is, let me put it here, kW equals 1 times 10 to the minus 14.54, then this must be true for that. But this is the hydrogen ion concentration and that is the hydroxide ion concentration. Therefore, pH equals 7.27. One of the things you're expected to remember is that water ionizes to H plus OH minus, partially ionizes to H plus and OH minus, and it's an endothermic reaction. As the temperature increases, then the kW for this increases as well. So that at normal temperature, room temperature 25 degrees centigrade, kW for water is approximately 1 times 10 to the minus 14, whereas at 50, I told you there, 50, it equals 5.48 times 10 to the minus 14. And it goes up to, amazingly enough, it goes up to, at 100, You're not expected to remember these. You're not expected to remember these. It goes up to about 51 times 10 to the minus 14. And at 0, kW0, it goes down to 0.11 times 10 to the minus 14. But you are expected to remember that as temperature increases, kW increases because it's endothermic. Those you are expected to remember. So, what is the pH of this water? So what we do is kW equals concentration of H plus times concentration of OH minus. This is the equation for kW. They tell us it's 5.48 times 10 to the minus 14. And we know that this has the exact same concentration as that in water, so it's H plus squared. So we want to find the square root of this. The square root of that times the square root of that. That one's the easy one. 10 to the minus 7 equals H plus. And the square root of that is approximately, it's greater than 2 and it's less than 2.5. Let us say it's 2.3, approximately 2.3. Therefore, the pH equals, well, that's minus 7 plus the log of that, which is approximately 0.3, approximately, equal approximately 6.7. And I would therefore say that this is the answer. There are a number of things you have to remember in doing this. First is you do have to remember in pure water, concentration of hydrogen ion equals the concentration of hydroxide ion. Therefore you can do this. You also have to remember how to do a square root of this kind of number. You halve the power, minus 14 goes to minus 7, and then you just have to make some kind of approximation, because in paper 1 you do not have a calculator. It's clearly somewhere between 2 and 2.5. And I've done 2.3. You could have done 2.2, whatever, 2.4. You do need to have a quick, dirty method of calculating a square root. And it's just over 2.3. Then you do the pH. Now you need to know how to do a log of that number and that number. The log of that number is easy. It's minus 7. The log of that number is minus 7. The log of that number, you simply have to remember it's approximately 0.3. Log of 2 is approximately 0.3. So then you do this. It's plus 0.3 minus 7, which comes to minus 6.7. And the pH is minus the log of that. So it comes to 6.7. And then you get 6.6. This is one of those questions that, in my view, can take you nearly 60 seconds to work it out. But it's still a lot less than 1.5 minutes, which are allotted. And if you've done this one a few times, and remember this, as the temperature rises, the kW rises. If you remember those things, this question can be straightforward. I always find it surprising that they actually tell you the value of kW equals 1 times 10 to the minus 14. My view is you need to remember it. What is the concentration of hydroxide ions in an aqueous solution in which the concentration of hydrogen ions is that? The way I would do it is to put down the equation for kW, and then you know the value of H plus, you know the value of kW, the only unknown is the OH minus. So kW over H plus equals OH minus. kW is 1 times 10 to the minus 14. concentration of H plus is 2 times 10 to the minus 3. You do not have a calculator, so what I do, I would calculate the value of that, and then I would calculate the value of that. So that equals 0.5 times 10 to the minus 11, and that equals 5 times 10 to the minus 12. And there is the answer. This is one of those that is relatively straightforward. If they tell you hydrogen ions concentration and Kw, then to determine the hydroxide ion concentration, you simply have to remember this relationship. And if they did it in the other direction, if they tell you the concentration of hydroxide ion and Kw, you can work out the concentration of hydrogen ion. Or they could tell you the concentration of hydrogen ion and hydroxide ion at some unknown temperature. You could work out the Kw.
Students look at this and the numbers float in front of their eyes, and they wonder how they're going to calculate both the hydrogen ion and the hydroxide ion. Well, the reality is all you need to do is calculate the hydrogen ion, because all the hydrogen ion values are different. So if you've got 1, you've therefore got the corresponding hydroxide ion, and therefore you have the answer. And if you look at this, they say it's a weak acid, they give you the strength of the weak acid, and they give you the K value, the acid dissociation constant. And therefore you are in a position to calculate the exact amount of hydrogen ion. Start off by doing HA goes to, it's a weak acid, so it's reversible, H plus A minus. And then, because they've given you the Ka, you then write the Ka equation. H plus A minus over HA. All these are concentrations. Now, the important thing is to see that the concentration of hydrogen ion equals the concentration of the A ion. H plus equals A minus. Therefore you're in a position to substitute the A minus here and put H plus in its place. So you end up with this, H plus squared over HA there. You know the Ka, you know the HA. The Ka is 1 times 10 to the minus 7 equals H plus squared over, and the concentration of HA is 0.1. Therefore, H plus squared equals 1 times 10 to the minus 8. That's 10 to the minus 7 times 10 to the minus 1. H plus concentration equals 1 times 10 to the minus 4. And there is the answer, C. It's something that you can do within 15 to 20 seconds. As soon as you see that they say it's a weak acid and they give you the Ka, then immediately you can go to this equation. Immediately. Because with the Ka and the concentration, you can then work out the hydrogen ion. You could then work out the pH value. Once you've got hydrogen ion, you can get pH value. And once you've got the pH value, you could even work out the pOH value. So really, there are a number of possible columns they could put here, and it's the same question. It could be pH, pOH, etc. And it's the same question. Remember that. The important thing to remember is that if they tell you it's a weak acid, they give you the concentration of the solution, and they give you the Ka, you immediately can work out the hydrogen ion concentration, the pH, and the pOH, and the OH minus, if necessary. As I said, it's a question that you can do in less than 20 seconds. This one is similar to the previous one, except that we're using a weak base instead of a weak acid. And in this case, because it's a weak base, we'll simply try and find the OH minus concentration from this column. And once we've done that, we don't need to bother about that column. We know the answer. So let's look at this weak base and the equation for it.
let's say it's B plus H2O goes to BH plus, and the B can be ammonia, ethylamine, methylamine, many possible weak bases, plus OH minus, and the KB equals BH plus OH minus over B concentration. Now, the things we know. We know the KB. 1 times 10 to the minus 7 equals. We know the value of B, or the concentration of B, 0.1. And in addition, what we do know, because of this equation, we know that BH plus concentration of equals OH minus concentration of. Therefore, we can substitute BH plus by OH minus, and we have OH minus squared here, and therefore OH minus squared equals that times that, which is 1 times 10 to the minus 8, and therefore OH minus equals 1 times 10 to the minus 4. There we go. C. Don't have to bother with H plus in this particular question. You may be able to do this in your head, but if you want to write it down to just make sure you don't make a mistake, that's fine. It still shouldn't take you more than 20 seconds. Based on the previous exercises, you will realize that there are two ways of doing this. The first is to accept that this reversible equation is endothermic. And therefore, when temperature rises, the K for this, or the Kw for this, also rises. This means the concentration of H plus rises. Of course, the concentration of H plus is always equal to the concentration of OH minus in water, but for the moment we don't have to bother with the OH minus. We're just looking at the concentration of H plus. That rises. As concentration of H plus rises, the pH falls. Now we go over to this series of temperatures and Kw. As we go up this column, the temperature is rising and the pH is falling. Now we know that this one, the pH equals 7, because that's water at approximately room temperature, 25 degrees centigrade. We know the pH equals 7. We know that the pH on this side falls as we go up the temperature scale. Therefore, the pH here is going to be greater than 7. And they've told us the pH of this sample is 7.47. There is only one possibility, and that is this one equals 7.47. So the answer is D. Simply because we know that this equation is endothermic, and as temperature rises, we know pH falls. So there can only be one answer, D. So that's one way of doing it. The second way of doing it is to remember that Kw equals the concentration of H plus times the concentration of OH minus, and when Kw equals 1 times 10 to the minus 14, and we know that the concentration of hydrogen ion equals the concentration of hydroxide ion. We know that the H plus is 1 times 10 to the minus 7, and the concentration of OH minus is 1 times 10 to the minus 7. So all we do is we substitute these 7s for 7.47. So that's at 25 degrees centigrade. We now do it for naught. No, we don't. We do it for an unknown temperature. It's an unknown temperature. I'm assuming that it's going to be the same answer. So 1 times 10 to the minus 7.47 and 1 times 10 to the minus 7.47. 7. And that will equal 1 times 10 to the minus, and you simply add those together. It comes to 14.96, which is more or less 1 times 10 to the minus 15, which equals 0.1 times 10 to the minus 14, which is the same as that. I would think that this one is probably faster, but if you like mathematics, if you like calculations, this is the other way of doing it. And they both give the same answer. And whichever way you do it, you can certainly do it in less than 30 or 20 seconds. If you found this YouTube video helpful, please subscribe to my channel, Solutions in Chemistry, and look at my other videos. Thank you.